Hey, let me quickly run you through my ideas for the Z-axis. So I use heavy roller bearings with the connections from behind so that I have a flat surface here for my sealing lip. I have milled down this plate 3.5 millimeters, like the specs of these rails want it to be, so that they sit on this reference edge here. And I use these center nuts to press them against this reference edge. So I have several of these center nuts, screws from behind, so I have this surface and this reference edge, which gives me a perfectly aligned and straight rail. On top of the rail, we have 4 of the standard roller bearings of the carriages. So the next part I want to show you is the set assembly. So the idea here is, of course, there's a NEMA that drives the whole thing. This is pretty standard in terms of the bearings. I have a pocket milled here with a this is annoying. The pocket milled so that the surface is a defined area, and this edge together with this hole for a dowel pin gives me an exact position for the housing. So you see there's a gap, and I use the surface, this edge, and this dowel pin to define where this housing sits, and the same here. So there's an edge, and I use this surface, and this pin to define the alignment. So nothing spectacular. There's a 1605 ball nut in it. Let me go to the plate. So the plate that sits on top gets 4 of these bars for extra rigidity. The ones that sit on top here can be even taller if you want to give it more rigidity. And then I have several holes for different mountings. So these holes here are for a very specific spindle that I want to use on this machine, but these threads here are for the standard 80mm Chinese spindles that are available all over the internet. So this moves up and down, nothing special. And I want to protect the rails from getting too dirty. I know that the sealing lips are very good nowadays, so you don't really have to protect them, but I think it looks better, and so this is what I did. So in terms of housing, I use bended sheet metal on left and right. There's going to be Teflon tape here so that it slides here. I think that I will use some kind of tape to protect these corners here from movement and noise, resonance. This part here is a laser cutted plastic part, just with a very tiny gap so that dust doesn't come in too easily. And on top here there are 2 pieces of sheet metal where I will have a piece of leather that hangs from here, goes down here and up here, and then it's connected. So this allows the movement and will close this area. Electronics. So I have these clamps up here. So all the wires will come from the energy chain at this point, will go into this box, onto this clamp, and then here you see all these do is connect the wire from here to there. But you can document very easily which wire goes where. You can interchange parts easy. You can measure from your control cabinet to these connectors. So I think it's a very useful way to connect this spindle or the whole assembly to the control cabinet. And of course you can pre-assemble this whole spindle and then connect it afterwards. So it's the way to go. In terms of the end stops, I went for optical end stops. There are these 3D printed mounts for these sensors, and there is this 3D printed part that then goes in between here and whenever I come to stop. So this will activate this here, and I am able to slightly adjust it to the position that I want to. I am thinking about a fail-safe mechanism here for the whole axis. So whenever this breaks, the whole assembly will fall down at the very moment. So maybe I need a screw here just to protect that from happening. And anything else? Yeah, let me show you something. So there is the blade on top. So I figured it's very important to do the CAD drawings with all the screws, because I forgot that the screw heads have to travel their way as well. So this is why I have these two grooves here. And I just changed the length of the whole assembly and just realized that I have to extend this very groove. So good that I made this video for you. So let me finish with the spindle. This is an ISO 2200 with an automatic tool changer. It can travel from here to, you see. Let us look inside here. So this is the travel that we have. Unfortunately, because I wanted to have a longer Z-axis, now this whole assembly isn't very pretty. So now in the very top position, this is now open. I'm not sure yet how I will handle that. Maybe I have these threads here to later add parts like the lights or set probe and the DAS for the vacuum. So maybe I will have a sheet metal that closes this part. But as soon as the tool is really working, they will close this gap. So this is my first design for a Z-axis. I will continue with the portal. That is going to be a mineral casting. And yeah, stay tuned if you want to see that. Bye.